Hello, Math 006. What we are looking at in 10.2 is rational numbers as exponents. So we're going to be working with exponents. The nice thing about this section is you've done the exponent rules before, whether you took Math 005 or if you had a math course right before you came into this from high school or whatever it may be, this is going to be using all of those exponent rules. The only difference here is now our exponents are going to be a rational number, meaning we're going to be seeing fractions as our exponents. So the first thing here says explore rational exponents. This is going to be something where if we have a base of a, and then we're going to be raising it to an exponent. And just for the sake of this little exercise, I'm going to use 1 over n. So I want to use, okay, a to the 1 over nth power here. Now, let's go ahead and put some variables in for the a and the n, just so we can see what happens. Let's say, okay, in place of the base of a, let's put the number 9. And then in place of that denominator in the exponent n, let's put a 2. So now what I want you to do, I want you to use your calculator and type in 9 raised to the 1/2 power. You can use the exponent button above the division sign and then either type 1 divided by 2 or use the fraction template. So go ahead, pause the video, type that in, and figure out what you get. Okay, you'll notice that when you type that in, 9 to the 1/2 power, you get 3. And that is because this rational exponent is going to be the same thing as a square root. So in this case, we'd have the square root of 9. Now this little 2 that we see here as the denominator, that's going to be the same number as our index that we see with our radicals. Now in this case, the index is 2, so we don't write it. But these two things hold the same value. And you can see that is what we have here right on the right. This is the definition that we are using. You have 1 over n, and our n is going to be our index. Our base is our radicand. Okay, the next thing we're going to be doing is just doing some changing from exponential notation to radical notation and vice versa. So what I want you to do, I want you to actually pause the video and try out the next 8 problems. We kind of did an example in the top, so see if you can use that to work through those problems as best as you can, and then come back and we'll go through them together. Okay, I at least did the first one of each of them just to make sure you're on the right track before we go through the rest of them. So in number 1 here, I let we're talking about 2 variables here, the a and the n. So I let my a be m because my a is my base, and my n is the denominator, which in this case would be 3. Now following the form that we just talked about up here, it's the nth root of a. So our denominator becomes our index, and our base becomes our radicand. So it's the cubed root of n. We're just going to leave it like that for now. The next one, number 5 that I did, we know that our radicand is our base of a, and our index is the n there. So we know it's going to be 19 to the 1/3 power. Okay, so now if you didn't finish the rest of them, go ahead and do that. If you did finish, just keep watching. We'll go over those answers in just a second. Okay, let's go ahead and see how you did with those. Number 2, we have 9 and the square root of 9x to the 8th. Now you'll see I put a little red asterisk by this one. That's because we will see in a couple sections that we can actually simplify this radical because we know that 9 is a perfect square. The square root of 9 is 3. And we're also going to learn that x to the 8th is also going to be a perfect square. And we'll learn about how that simplifies in another section. But for now, we're just going to leave the square root of 9x to the 8th. Number 3, we have the fourth root of the square root of, the fourth root of x cubed, y cubed. And again, the 4 is the index. Then we just put the base as the radicand. And then the last one is the 5th root of ab. Now, we already did 5. Now, 6, 7, and 8. I did not put the box around the answers yet because there's a little bit more we have to do with these. If you have them just as I see them, great, that's a perfect start. However, we need to include parentheses around these because, for example, this first one, xy is the radicand. So that means the whole xy needs to be the base. So we need to put the parentheses around that. Without the parentheses, if we would leave it like this would be x times the 5th root of y, and we don't want that. So let's go ahead and let's get rid of this here. Oops, and I lost my And then, so this was a y here, and then we want to put the parentheses. Now this would be complete. Same thing here. The base is the 5x. And again, we have to put parentheses around this base as well, because the whole radicand becomes the base. All right, the next idea, exploring more rational exponents. Now what we're going to do is change the numerator to something other than a 1. So if this is going to be in the form of a to the m over nth power. Now it's going to be similar in the idea of it's still going to be, when we simplify this, the a is going to be the radicand and our index goes here. But now what we're going to do is take that numerator of the m and we're going to place it as the exponent. The other way that we can write this is going to be the nth root of a, and then we can raise this whole thing to the mth power. Now that's all, everything to the right there says I just wanted to walk you through it. Okay, again, I want to go through I'll do 9 and 12 with you, and then I'll give you a moment to work through these on your own to see how you did. So we want to write an equivalent expression using radical notation and simplify. Write both forms. When it says to write both forms, that means that we want to write it in both of these forms that we looked at up here. That's what that means. So for the first one, we have x to the 7 over n. Well, we know x is going to be our radicand, meaning that's going to be what is inside of the root. And now 2 is going to be our index, so it's a square root. We don't have to write anything different with that. And then it's going to be x to the 7th. So we can write it like that. Or the other way to write it is going to be the square root of x to the 7th power. Now that one isn't going to simplify at all. Letter B. Oh, I'm sorry, number 10, but I'm going to let you do that one on your own. And then let's go ahead and look at number 12 then. So we want to rewrite an equivalent expression using exponential notation. So just to remind us that the exponent in the inside, this is going to be our m, if you will, and the index out here is going to be the n. So now this one, we have a base of n to the 4/5 power. So go ahead, pause this, and work through the rest of those and see how you do with it. Okay, we can see for number 10, we get the 5th root of b cubed, or we can take the 5th root of b cubed. I'm going to skip number 11 for now and come back to that one. Number 13, we have a to the 5/2 power. Number 14, we have xy to the 3/5. Keep in mind the xy needs to be in parentheses since the whole thing is the radicand here, or the base. And number 15, we have 7xy is the radicand, so 7xy is our base to the 4/3 power. And that would be our answer for that one. Now I said we were going to come back to 11 because we had to simplify this one a little bit. You can see the two forms here, the cubed root of xy squared, or the cubed root of xy, and the whole thing's being squared. All we're going to do is simplify inside this radical by distributing the power of 2 to the x and the y to get the cubed root of x squared, y squared. Good, let's move on to the next page. Okay, next we're going to look at is negative exponents. This is going to be a little bit of review if you had Math 005 or some other math classes. What I want you to do first is type 9 to the negative 2 power in your calculator. And when you do that, you're going to get a decimal that's approximately 0.01234567, and it goes up from there. Now, what I want you to do is hit Math, Enter, Enter to change that to a fraction. And when you hit Math, Enter, Enter from there, we hit Math, Enter, Enter, and we are getting 1/81. Now, how we can go right from this to this without having to use our calculator is by the negative exponent rules. So what this tells us, and whenever you have a negative exponent, say x to the negative 2 power, that's going to be the same as 1/x squared. So using that idea, we could take this 9 to the negative 2 and make it 1/9 9 squared, which is 1 over 81 comes from. The same rules apply with the negative rational exponents. Again, we just have a fraction as an exponent instead of an integer. So let's go on to the next one. Write an equivalent expression with positive exponents and, if possible, simplify. So one thing you always want to keep in mind that if it's not written as a fraction, you can always write it as a fraction by putting a 1 in the denominator spot. Now, in order to create a positive exponent, we need to take that base and negative exponent and move it to the other side of the fraction bar, whether it's going from the numerator to the denominator or the denominator to the numerator. So when we do this, we then have a 1 in the numerator of our fraction now over y to the 3/4 power. And for the sake of this, we're just practicing with the negative exponent, so we're going to just leave it like that for now. The instructions here also say, if possible, simplify. But in this case, we're not going to be able to simplify it. Only if we have an integer as a base would we be able to try to simplify these. So let's keep going. Number 17. We still see that we have this negative exponent, so we need to address that. Again, keep in mind this whole thing is over 1, so we need to take the base in the negative exponent and move it to the denominator. So now we have 1 over 5xy to the 5/6 power. Now we do have an integer as part of the base, but we're not going to be able to simplify 5 because that's not going to be a perfect square or perfect cube or anything of that nature. So now let's look at number 18, slightly different because now the negative exponent is in the denominator. We need to move that to the numerator. However, we don't want to do anything with the 3x because that already has a positive exponent. So we're going to leave the 3x alone, but then we have to have y to the 5/7 power. You could put a 1 underneath it, but when we simplify, we don't ever write the 1 underneath it. And we don't want to use parentheses here because the y is the only thing that's getting that power of the 5/7. Now, we have a whole bunch of stuff going on in number 19. First thing I'm going to do is put the 1 underneath it. Now, we see that this y to the negative 1/2 is the only thing that has a negative exponent. So that we need to move to the denominator, but everything else is going to stay as it is. So we have 2x to the 3/4 power times z to the 2/3 power, and we're going to divide all that by the y to the 1/2 power. And that's going to be our final answer there. Now, if the question asked us to change everything to radical notation, then we would have had to do that. But for here, we're just simplifying those negative exponents. Okay, the next idea I'm going through, and you can see I filled in everything below the law of exponents. This is just going to be a little bit of review of how we work with our exponents. You can see that I wrote the rollout in the blue, and then in the red, yellow, the other colors, I worked through an example so you can see how it works. It's not about memorizing the rules, but more so it's about understanding how exponents work. So the first one, if you have the same base that are being multiplied together, think of it as x squared times x cubed. If you were to expand these into 2x's and 3x's, you would add those exponents to get 5. So the rule here is to add the exponents when you're multiplying two of the same base. To the right of that, we have a quotient. So again, the same base. Here we're going to subtract the exponents. I did two examples here because you face two different things. The first example, the exponent in the numerator is higher. Again, I expanded them, crossed things out that cancel. You're left with x over 1, which is equal, it simplifies to an x. Now, with the one I did in pink here, the exponents are reversed. So the larger exponent is in the denominator. Here, when you cancel, you're left with the x, but it's in the denominator, so your answer would be 1 over x. Now, you can still use the rule. X2 minus 3 would be x to the negative 1, which we know that we talked about in the top of this page, would be 1 over x. The next one, the third one, is we have a power to a power. So again, you take, okay, if I have x cubed squared, that means we have 2 of these. So I wrote x cubed twice. If you were to expand each of those and count them all up, you'd get x to the 6th. So here we multiply the exponents. And the last one, a times b to the mth power, we're going to distribute the power of m. And this is something that we did on the previous page. So if we have xy cubed, that means we have 3 of these xy. So xy times xy times xy. Now by the commutative law, I reordered everything and I end up with x cubed, y cubed. So I'm going to take a minute, copy those down. If you have any questions, please reach out. All right, applied together. So when they're being multiplied, that's going to be this rule here, which means we need to add onto the final page here. The first one says, use the law of exponents to simplify. Do not use negative exponents in any answers. So now this is just practicing those rules. We just have fractions in the mix of this. If you need to, use your calculator. I'll do the first one with you just so we can see what we're going to do, and then I'll have you try out the rest of them. So the first one, we have a base of a. Again, you always want to make sure if you're dividing or multiplying, you have the same base. And just like we looked at the previous page, where they're being multiplied, those exponents. So we need to add the exponents here. So we have a base of a, and we're taking 2/3 plus 1/2. Again, if you need to, use your calculator to do this. But to keep in mind, to multiply fractions, you have to make sure that you find a common denominator here. So it doesn't matter how you work through it. Again, I recommend using the calculator unless you're comfortable with fractions. We do 2/3 plus 1/2, and we get 7/6. So this would be a to the 7/6 power. Now on the homework, I would ask that you write out the step right here, just so I can see that you know which operation you need to use. So just to quickly give you an idea here, number 21 is a quotient, so we'd have to subtract our exponents here. Be careful with that negative. 22, we have a power to a power, so you'd have to multiply. 23, they're being multiplied again, so you'd have to add. Again, be careful with the negative. And then 24, this would be like the last one we looked at. This is where you have to distribute that. So go ahead, pause the video, and see how you do with it. Okay, you can go ahead and look at the answers that I have for you here. A couple things I want to warn you about. Number 21, remember you have to subtract a negative 2/11, which turns that to a positive. Number 22 should be pretty straightforward. 23, you get a negative, so you have to make sure you move that to the denominator because we do not want negative exponents. Number 24, we get a negative rational exponent. We also get one that we need to simplify, and you can see how I simplified it there. Okay, moving on to the next one. Use radical exponents to simplify. Do not use fractional exponents in the final answer. All right, so the first one, we set this up as x, and we know that it's 15/3. Again, the index here is our denominator. So 15 divided by 3 is 5. No no fractional exponents, so we're good there. The next one, we have t to 6/10 power. Now we know 6/10, they're both divisible by 2, which would simplify to 3. But that has given us a fractional exponent, our answer, so we want to then convert it back to radical notation. So we know that our denominator is our index, so that is going to be our index. So we now have the 5th root of t cubed. We're going to leave it like that. Number 27, we have 3x to the 2/8 power. Well, we know this would be 3x to the 1/4 power, which again, we do not want a fractional exponent, so we could rewrite this as the 4th root of 3x. And then go ahead, I want you to pause the video, try number 28. Okay, checking our answer here. For number 28, we'd get x squared y to the 5th to the 12/3 power. We know 12/3 is equal to 4, and then we have to distribute the 4 to both those exponents to get x to the 8th, y to the 20th. Now, looking at this last one, we have a word problem here. It tells us that musical frequency, the function given by f of x equals k times 2x over 12 power can be used to determine the frequency in cycles per second of a musical note that is x half steps above a note with frequency k. So what I want to do first is define our variables. It tells us that x is the number of half steps, and it tells us that k is going to be the frequency. It's important that we write out what the variables are so we know how to proceed with the problem. The frequency for concert A for a trumpet is 440 cycles per second. So that's going to be the frequency for the trumpet. So that's going to be 440. And it tells us find the frequency of the A. That is 24 half steps. So this would be 24 half steps above concert A. Show work to support your answer. So we're substituting in the two values here. We're taking in, we're taking in 24 and 440. So now what we want to do, we want to simplify the expression here on the right. So let's say, okay, we know that our K is going to be 440. And we're multiplying that by 2 to the 24 over 12 power. And then we want to continue to simplify this. We know this 440 times 2 and 24 divided by 12 would be 2. Now think of your order of operations. We always want to simplify exponents first here. So we have 440 times 4, and then we do that, we get 1760, and this would be cycles per second. Cycles per second. We know this because it says to determine the frequency in cycles per second. Again, on any exam or anything, show work to support your answer. You'd want to show all of that. If you have any questions on anything, please reach out to me, and good luck on your homework assignment.